Let's discuss solving differential equations using the integrating factor. Now, when you have a differential equation in the form dy by dx plus py is equal to q, then what is called the integrating factor is equal to e to the integral of p dx. P is the constant or the function that multiplies y. Alright, so you have e to the integral of that dx. Now you multiply both sides by the integrating factor. So you multiply by e to the integral of p dx. Now, what you're going to have is e to the integral of p dx multiplied by dy by dx plus e to the integral of p dx multiplied by py equals e to the integral of p dx multiplied by q. Now, let's rewrite this. What you have is e to the integral of p dx times dy by dx plus this p, let's put it in front of the e to the integral of p dx here. So you have p e to the integral of p dx times y, and that is equal to e to the integral of p dx times q. Now let's look at this. What's happening here? Now you notice over here you have dy by dx, and you notice here you have y. So what you did was you differentiate y, but what you did over here is that you keep y, you hold y as it is. Now here what you have is e to the integral of p dx. Suppose you differentiate e to the integral of p dx, what would you get? Well, this is what you get. You have the e to the integral of p dx, and you multiply it by p, right? It's just like when you have e to the 5x. When you differentiate that with respect to x, you get back e to the 5x, yes? But it's multiplied by 5. Similar situation. So here, what you do is you hold e to the integral of p dx, and what you do here, you differentiate e to the integral of p dx. Alright. So here now, what you really have is the result of differentiating using the product rule. And you can see that the product is, remember, you hold y, differentiate y here. One of them is y, and the other product remember you hold e to the integral of p dx over here, or you differentiate it over here, is e to the integral of p dx. Alright? Now that is equal to e to the integral of p dx times q. After that now, you integrate both sides. The integral of this equals the integral of this. Oh no, wait, hold on. One thing. Remember, you differentiated y(e) to the integral of p dx. So I need to show that it was differentiated. What you find is the derivative with respect to x of this product, y(e) to the integral of p dx, in order to get what you have up here on top. You differentiate this product here to get this. So when you differentiate it, you hold y, differentiate e to the integral of p dx plus, you hold e to the integral of p dx, differentiate y. Alright? Or you can consider that you hold e to the integral of p dx, differentiate y, plus you hold y times differentiate e to the integral of p dx. So this is what you have. When you integrate the derivative of any function, the function is left as is. So what you have is y e to the integral of p dx. It's like the integral and the derivative cancel each other out, leaving the function undisturbed. Right? So that is equal to the integral of e to the integral of p dx times q. So we can finish up by saying you differentiate, you divide by e to the integral of p dx. What you're going to get is y equals the integral of e to the integral of p dx. All of this is divided by e to the integral of p dx. And you have your q here. Then you have your plus your constant of integration. When you're using numbers, the integral of p dx would work itself out. So you don't have to worry about having an integral of something another, the integral, and divide by the integral. These would work out. Alright? So basically, that's our discussion on the idea behind solving differential equation by using the integrating factor.